All right, guys, welcome back to Math Analysis. We are going to continue on with our packet today, working on the second page titled Avogadro's Number and the Mole. Now, we talk about Avogadro's number in the title here. What is Avogadro's number? Think about it, you know it. What is it? That's right. 6.022 times 10 to the 23rd power. Absolutely huge number, right? Massive. But that is the number of atoms that are in a mole. That's the number that you got to get together to make the atomic mass of an element be the mass of that element in grams. Kind of a weird thing to say, but that's what it is. So, we have some questions on this page. Number one says, how many moles of water does 6.02 times 10 to the 23rd molecules represent? Well, here's what I'm going to look at, and I'm going to see that number, 6.02 times 10 to the 23rd. That is Avogadro's number, right? Now, I know we have 6.022. It's close enough. We ask ourselves, how many moles is that? If that's how many molecules of water, of H2O, that we have, how many moles is it? Well, if it's this many molecules, that means it's 1 mole, right? That's how many moles this is. That's 1 mole. I'm going to write that up here. I'm going to say this number of atoms equals 1 mole. Because we're going to be doing some conversions on this paper. So the second question, this is more of a real question. That first question is dumb. I don't like that question. Question 2 says convert 3.01 times 10 to the 23rd molecules of C2H6 to moles. So here's what I want to ask first. Here's a really important question. This specifically said C2H6. The previous question specifically said H2O. Question 3 says CaCl2, calcium chloride, right? Does that matter? Does the number of atoms in a mole, or the number of molecules in a mole, have anything to do with what compound it is we're working with? Does it matter that this was water, that this one is C2H6, that the next one is calcium chloride? Does that matter? The answer is it doesn't. It means nothing. No matter what element, compound, anything we have, this is the number of atoms in a mole, plain and simple. So, this information, it's irrelevant. All we care about is how many atoms there are. So what we are going to do is we're going to do some old school conversions here. Some kind of conversions like you probably did in 6th grade. We are going to figure out how many moles we have. What we're going to do is we are going to write the atoms we have. And I'm going to put have in quotation marks, because we don't really have the atoms, but that's how many atoms we're working with. And we are going to divide it by the number of atoms in 1 mole. I don't know why I wrote the number sign before the 1 there. That makes no sense. But the number of atoms in 1 mole. So that would mean we have 3.01 times 10 to the 23rd. In 1 mole, there's 6.022 times 10 to the 23rd. And we're going to divide these numbers. Now, something important comes up because we are dividing numbers with scientific notation. Here's what I recommend we do. We should divide each of these separately. You know how if you had a number and a variable, like 3x squared, and you want to divide it by something else, 12x to the 5th. Well, you would divide the 3 and the 12, you'd simplify those, and then you would divide the x's separate, right? We do it one step then the other. That's what we do with scientific notation as well. We divide the whole numbers at the beginning, and then we divide the scientific notation. So here's what I'm going to do. I'm going to take 3.01 divided by 6.022. I'm going to do that first. Well, guess what that gets me? You probably already know. That gets me right about 0.5. That's what it is. Now, what I'm going to do next is I'm going to drop my multiplication sign right here. That just drops down. And then I'm going to divide these. Now think about this. 10 to the 23rd over 10 to the 23rd. What is that? What's that simplify to? That's right. It's a number over itself. It's something divided by itself. That's just 1. That's just 1. That's all it is. So 0.5 times 1, well, that's just 0.5. And that tells us that in 3.01 times 10 to the 23rd atoms, we have exactly 0.5 moles of atoms, 0.5 moles of molecules. Let's do one last problem here. Let's do number 3. Number 3 says how many moles of glucose, C2H6O12, actually it might be C6H12O6, don't quote me on that, are in 2.14 times 10 to the 24th moles. Okay. So we have 2.41 atoms times 10 to the 24th divided by the number of atoms in a mole, 6.022 times 10 to the 23rd. So here's what's going to happen. We're going to divide these, right? So 2.41 divided by 6.022, well, that gets us 0.400. So I'm just going to say 0.4. So this portion gets me 0.4, dividing those whole numbers. I drop the multiplication sign, times, and then we divide these. Now let's think about what would we get there? 10 to the 24th divided by 10 to the 23rd. Here's what happens. It's very similar to dividing variables. We cancel out the exponents when possible. Okay? So we have 24 exponents in the top, 23 exponents in the bottom. Whenever we're dividing things with exponents, we can just subtract those, and the remainder of that, the difference of them, stays where the larger number was. So we can take 24 minus 23, well, 24 minus 23 is 1, and then that 1 remains in the numerator with the 10 up top. So we would get 10 to the first, or just 10. So what we would do, after dividing each of these, we multiply them. 0.4 times 10, well, that gives us 4. And it tells us we would have exactly 4 moles of glucose. 4 moles. All right, here's what I want you guys to try out. Try out numbers 4, 5, and 6 on this page. Try out 4, 5, and 6. We just did 1 through 3. Try 4, 5, and 6. See how those go. If you have any questions, let me know. I'll be happy to help. Otherwise, see you guys tomorrow.